We've been talking so far about like atoms and elements, molecules, compounds, but we are now moving on. So I hope you guys have noticed a trend that as you go further into like the textbook and just in this class, we are building on what we're learning, right? We started with like the ABCs, the elements, and then we started forming words, so like molecules and compounds, and now we are going on to sentences and paragraphs like chemical reactions. So just think of what you've been learning about as like if you're learning to talk basically, except about chemistry. So chemical reactions have their own like details about the language of it, and most importantly, we have two major like players in chemical reactions. We have our reactants, and then we have our products. Um, Please be aware that elements are not transmuted during a reaction, they are just rearranged. So all you do is you rearrange elements from being in one type of compound in the reactants to a different one in the products. But you can also think of it like we are starting off with like raw material or ingredients in you cooking something, and then your final product is whatever you cooked or baked. So we're going to start by looking at one of the most common reactions that like you use in your daily life. Well, that's if you have a gas stove. But methane gas comes out of a gas stove and it reacts with the oxygen in the atmosphere. And that actually is what causes the burning. So any type of like burning reaction is actually called combustion. So specifically for this, it's combustion of methane, and the products that you get are carbon dioxide and water. Um, when this in this particular reaction, if you look more closely at it, we actually notice some issues with it. So on one side of the reaction, you have two oxygen atoms, and on the other side, we have a total of three. So something isn't balanced, and we are going to learn how to do that and why it's so important to have balanced chemical reactions. Essentially, whenever you balance this is what you'll get. You will get a 2 in front of this oxygen and a 2 in front of this water. Now, there's a process to this, so it might take a little bit of like a learning curve, especially for some of the more complicated chemical reactions you have to balance, but just know the more you do it, the easier it'll be. And what essentially we do is we are going to change the numbers in front of every reactant or product in order to get the same amount of atoms on both sides. So here now you can see that we have 1 carbon, 4 hydrogens, 4 oxygens, same exact thing on the product side. So before we move on to balancing, I like to just bring up some other types of examples sometimes to be more relevant to just, I guess, biological stuff. I know many students are bio majors or you plan to go into the health field. So sometimes I just like to talk about like interesting stuff. So in your body, whenever you drink alcohol, basically your first line of defense for breaking it down is some enzymes within your liver called alcohol dehydrogenase. And they work to start breaking it down. It's not completely broken down, but they work to break it down, and you end up getting something called acetaldehyde. And this acetaldehyde is then broken down to further things. But essentially, all of these like metabolites, so the smaller compounds that come from the ethanol being broken down, are what give you that headache and that hangover. So it's just to show you that chemical reactions are occurring in your everyday life and even inside your body. And when you drink alcohol and you feel like crap, it's because of those chemical reactions working to break down that alcohol. So there are several important parts of a chemical reaction. I spoke about these first two, but you have the reactants and the products. The reactants is your starting material, just like we said, our raw ingredients. And then your products is what you get from those reactants undergoing a chemical change. What we show to separate the reactants and the products is an arrow. Whenever you get to Chem 2, you'll actually find that they start using double arrows, so um, it can get confusing, but for now, you don't have to worry about this just yet. That's Chem 2. Um, the plus signs that you have in chemical reactions separate components, so they'll either separate your reactants or your products. And then I also mentioned this right here. Coefficients are the numbers in front of the reactants or the products, and they tell us how many are reacting or formed. And generally, remember, chemists are lazy. We don't like to write things if we don't need to, so we'll omit one, but if you want to, you can write it. Another thing is the states. So you'll also see that we have some abbreviations in parentheses after each reactant or product, and this has to do with what physical state it's in. So you guys are familiar with these. I know you guys are fine with those, but this one you may not have seen as often. You may have seen it here and there in the textbook. AQ stands for aqueous, meaning that it's something that's dissolved in water. So most likely, if it's aqueous, it's usually an ionic compound because ionic compounds dissolve very well in water. So we are going to go through some examples of balancing equations. Now, I'm going through a few very specific examples, so please notice like what these titles say. So we are going to go through an example where we balance an equation with fraction coefficients. And this is a very, like, I want to go through this with you guys because if you don't like go through it with me, you'll literally sit there and spend like 30 minutes just like going down a rabbit hole trying to figure out this puzzle, and it somehow doesn't want to balance. So it has like a special trick to it. I know you guys can handle like regular, like easier ones, so we're gonna go through this one together. And this is like the general guidelines for balancing equations, so we're gonna follow this. So here we have C2H6 and O2 reacting to give water and carbon dioxide. So this is actually a combustion reaction. Combustion reactions always give water and carbon dioxide, and it's always something, a hydrocarbon usually, reacting with oxygen. So just so you guys begin to notice what type of reaction is the one that you'll need fraction coefficients for. So we are going to start off with writing out our chemical formula. We actually have everything written out. Next, we are going to start by balancing the complex structures first. So what I like to do is I'll just like set this up down the middle. And we have three types of elements, right? So which one are we going to start balancing first? Like which of these reactants and products are we going to start with first? So anytime you have an element present in more than one of the either products or reactants, that's something you want to leave for last. So for example, in water you have oxygen, in carbon dioxide you have oxygen. That means you need to stay away from oxygen at the beginning, leave it for last because that's the one that's going to give you issues. So what we're going to start with actually is starting off by trying to get these carbons and hydrogens balanced. So on this side we have 2 carbons, on this side we have 6 hydrogens, we have 1 carbon, and we have 2 hydrogens. Like I said, ignore oxygen right now. We'll fix it later. So on the reactant side, we have 2 carbons, so we are going to place a 2 in front of here to get now, and I'm going to use a different color. So now we have 2 carbons, right? And we're good with the carbons. Now, what about our hydrogens? So hydrogen has 6 on the reactants, and we only have 2 on the product, so I'm actually going to put a 3 in front of there. And then I'm going to cross this out, and now we have 6. So we have everything balanced except for oxygen. So now is when we can finally tackle the oxygens. So let's count them up. So I have 2 on this side, I have 3, right? This applies to that. So I have 3, and then I have 2 times 4, which is total 7. Obviously 2 and 7 is not balanced, so that means I have to fix something on the reactant side. Now this is the point where you have to realize, because this is an odd number, that means just adjusting like numbers here, putting like 2 in front of here or 3, it's never ever going to give you the number that you need. So we do this little trick, and I'm going to write it in a different color, where we use a fraction coefficient. So I'm going to put the number that you need is this one over 2. right? Whenever you multiply this over like a whole number, you end up getting, right? The 2 cancels out, you end up getting just the 7. So essentially that's what's happening whenever we put that fraction coefficient. Now, we're not finished just yet. So what you actually have to do to the entire equation to get rid of that fraction is you have to multiply everything by 2. So now that we went ahead and multiplied, this will be our final answer. Just getting this out the way. It'll be 2C2H6 plus 7O2 gives us 6H2O and 4CO2. So so now we have it balanced, and now you can check it. I didn't exactly go through these, but these are also things you have to keep in mind. Do not change subscripts. All I did was I changed coefficients. I never changed a subscript. You start with like one coefficient at a time. I took it one thing at a time. I took carbon first, and then I looked at hydrogen. Balance atoms that occur as free elements last. So for example, that oxygen, that's another rule that applies to that oxygen about why we leave it for last, because it's in its free elemental form. And then this is actually what we did right now. If your balanced equation has fractions, multiply by the denominator of the fraction to clear that fraction out. So this is our final answer once we followed all those steps. And if you want to, you can actually go ahead and like check it by just checking that, like you can split it again and check that you have all the same numbers of carbon and hydrogen and oxygen. So now we have another example where actually we have some polyatomic ions inside of some ionic compounds. So a very common kind of like step that students kind of lean towards is they'll start separating out these polyatomic ions, but you shouldn't do that because you will just waste time. Like it's very time consuming to do that, and it's just easier to do it this way. So your main idea whenever you have some ionic compounds like this, right? This is obviously ionic. This is a metal, non-metal. So I'm just reminding you of how to tell whether something is ionic. And also it's aqueous. So ionic compounds are the ones that are usually aqueous. And then also this has a polyatomic ion. So that's the polyatomic ion we're referring to. You should just focus on keeping them intact and then just balance the way that you usually would. So we have the chemical formula written out. We're going to start by varying the most complex structures first. And in all of these, I guess the most complex ones are the ones that have the most subscripts. For example, this one I would say is pretty complicated. So we're actually going to get started with that one. So let's start with SR first, which is strontium. And then we have phosphate, right? Phosphate is a polyatomic ion. There should be 3. So we're going to start with both of those. So we have 3 strontium on this side. We only have 1 on this side. We have 1 phosphate right here, right? We can tell it's only 1 because there's no parentheses around it. Right here we can tell we have 2 because there's a subscript after it. Okay, so obviously both of these are not balanced. The reactants have less than the products, so we need to figure out what coefficient we need to put in front of here. So because we have 3 strontiums on the products, we need 3 strontiums right here. So now we have 3, right? And then in terms of phosphate, we know we need 2, so I'm going to put 2 right here. Now, yes, this affects lithium and the chloride, but we're going to fix that right now. So now you can go ahead and move on to lithium and chloride. And I'm supposed to be writing these charges just to keep it accurate. Okay, so on the reactant side, we have 6 lithiums, right? Because we have that 2 and then we have that 3. So overall that multiplies. And then we have also 6 chlorides. Because we have that subscript times that 3 that carries out. So essentially all we need to do, because the lithium and chloride are bound together on the product side, all we need to do is add a 6 in front of here. And then that's basically it. So for equations that have polyatomic ions, keep the polyatomic ions together the way that I did for that phosphate. It will make your life so much simpler. And then just balance them as a whole. Um, and there's no fractions in this, so we're pretty much done. There's no free elements, so that's basically it for this one.